Thanks,
Okay.
Addie.
Thank you.
My role here, I'm kind of in between a student and a professor. I'm just a researcher. I help out around the department.
Oh, okay.
So I work with Addie, and this is another professor's lab. So
Okay.
each professor is kind of assigned a room.
Okay.
Like that, the ones that we were just in were Addie and her colleague Josh. This is one of my bosses, I guess, named Dan. This is where we make the simulant. This is not where. We have a warehouse elsewhere that we actually crush rocks up and put it all together.
Oh,
This
really?
is where we study it. So
Oh, okay.
if I...
You have a bunch of different stuff.
Exactly. So we got some. This one's like for an asteroid. This
Okay.
mimics an asteroid.
Asteroid stimulant.
We've got stuff.
So did y'all make it and make these labels, or did you buy it?
No, we make these. This is all made here through a NASA cooperative agreement. It's
Oh
a
my
big
gosh.
grant, pretty
Okay.
much. We make these non-profit and sell them to educators, researchers, and
Oh, really?
whoever
Oh,
wants
okay.
them. This one is our lunar Highlands simulant. So if you look at the moon, you see those two the darker spots and the lighter spots. Those are made of different rock.
Really?
They're different rock.
That's
And
why they're different colors?
that's why exactly. And so this is the lighter color one that is most of the moon. And I'm desperately trying to find the one that is the darker. It's right here. This is our lunar Mare simulant. The Mare is the dark parts and the Highlands are
seas.
the light parts. Yeah, the
Okay.
seas, exactly. You know your Latin. So
Yeah, I did take it.
these have the same minerals and rocks in them that you would find on the moon. And they also have those crushed to the right particle size. So if you go to the moon and you take a scoop and you look at it under a microscope, you can use fancy tools to say, hey, what size are these particles in here?
And they're that size?
And we make them match that size.
That's really fine.
It is
Are
very
they all
fine.
really fine? So,
Most of them. So the asteroid, it's hard to see in here, but it has a lot bigger chunks in it.
yeah, I can see that.
For various reasons that I won't go into long-winded explanations over. But we crush it and we send it through a series of screens that we call sieves to just get them to the right size we want.
Yeah, okay. So it's really that fine? Because I read someone lying about the thing about how, there's like fine at the like bottom, and then it's, bigger and bigger, and it's kind of a problem because stuff sinks.
Exactly. and study it, like part of that, what we're studying with this material that we make here on Earth is that kind of problem. That's exactly why we make this. Exolith Lab, the group that makes this, the group that I'm with, we're all involved.
Oh, okay.
We try to make high fidelity simulants, so simulants that match what we're trying to do really closely. And with that, you can study like the strength of these and their chemistry and stuff, and kind of approximate the moon, but here on Earth for relatively cheap.
Yeah, so you would so like, I guess instead of like legs, it should be like a flat surface landing, or
Who knows? Or maybe something even
can
crazier. Exactly.
can it turn into cement?
Well, one of the very good question. Yes and no. What they're trying to do is, so cement requires additional materials to make this into cement, but otherwise, like on Earth, yes, we could. But on the moon, how are we going to make, we need to build structures on the moon, but we don't want to take a bunch of stuff up there. You can melt this stuff. So this is just rock, and if you melt rock, you get, it's not magma or lava, but it pretty much is. It's a naming thing. Anyway, you get this melt and it solidifies. Do you know what obsidian is? Like volcanic rock?
Yeah, that's the kind of rock it turns into.
Yeah, exactly. And if you cool it quick enough, it turns into that. And that stuff can be very strong. And if you melt this and you pour it into a mold like you're forging, you can make building structures out of this. And that's what people are studying. People use this stuff to study that.
Oh, wow. So that would kind of work. So there's a way to make it like really hot and really cool?
Really hot.
Up
there's
there?
a bunch of different methods to do it. a lot of it uses solar energy or big generators that you take up there or whatever, but just get it really hot, like, I'm trying to think, above 2,000 degrees Fahrenheit. Somehow do it, and then you can make it into whatever you want. It's just like making a sword, doing blacksmithing here on Earth. It's just up on the moon. It's
That
really
would be,
cool.
that would be
Really
interesting.
cool, and that is where a lot of people in this field are trying to study, and this group is no different.
Okay, yeah.
So
So the first people who do that, they're like,
they made it.
They made
got
it.
Yeah, exactly.
like we can build on the moon now. So.
Exactly. Exactly. And that's the ultimate goal. So it's super cool work. You want to touch this stuff?
Yeah,
So
yeah.
I will say that it is a respiratory hazard, so like don't
But
breathe
we
in it.
have these cool
We have
masks now,
so you
so-
can just go in there, grab a little bit of it. It's gonna be there. It's gonna.
Oh
clean
my
you.
gosh, this is between sand and chalk dust.
Yeah, exactly. It is. The biggest thing in here is 0.5 millimeter, and it goes
Yeah.
down to thousandths of a millimeter.
Oh my gosh.
And it feels, that's what the moon probably feels like. And
Oh,
it sticks
wow.
to your finger, kind of.
It does.
Because the particles in there, we
They're all
crush
dirty
them.
now.
We crush them, and they break into jagged shapes. And what you're seeing there is those jagged shapes grabbing onto your finger and fingerprints.
Oh, okay.
And it's
okay.
just sticking there. I've got a sink over here. I'll let you rinse off your hands.